So we have measure of dispersion. A measure of dispersion describe the degree of variability of data around a central value, such as mean or media. Now let's use two classes score for example. Let's say class A. In class A, this is their score: 70, 72, 71. This is 71, 71, 69 and 68. And let's say class B, this is their own score: 50, 90, 30, 100 and 80. Now this is the score of student in each class. For student in class A, this is their score. For student in class B, this is their own score. Now the mean in this class is 70. The mean for this one too is 70. So both of them have the same mean. So our central value is their mean, which is 70. If their media is the same, we can take their media as central value as well. So let's use the mean. Since their mean is the same, the mean here is 70 and the mean here is 70 as well. So both classes have the same mean, which is 70, but the closeness of scores to the mean is different. 70 is their mean, 70 is their average. If you take a look at this set of data, 70 is very close to all of them. 70 is close to this one, but this one, 70 is far from this one, even though 70 is the mean. So we say this one is low dispersion and this one is high dispersion. Because the mean is close to this one, so there is low dispersion. There is low separation between the mean and the data set, but the mean is far to this data set, so there is high dispersion here. There is high dispersion here. So class A show more consistency among the student score, but class B show variability, and that is what measurement of dispersion deals with. It tells us how stable, how consistent data sets are. Now the measure of dispersion we have are: one, range. Range is simply the difference between the largest and the smallest value in data set. The formula is maximum value minus the smaller minus minimum value. And if you take this data set for example, if you want to find the range for this one, the smallest number here is 68 and the highest number here is 72. So the range is highest number minus the smallest number. So the range for this one will be 72 minus 68, which is 4. The range for this class A is 4. For this class B, the smallest is 50 and the highest is 100. So the range will be 100 minus 50, which is 50. And we have variance as well. Variance is the average of squared difference between each data value and the mean. So this is the formula for variance. If it is population, if you are dealing with population variance, if you want to find population variance, we use this formula. If you want to find sample variance, we use this formula. Standard deviation is the third measure of dispersion. This is standard deviation, the positive square root of variance. So standard deviation is just square root of variance. This is variance. So this is what we use to denote um population variance. This is what we use to denote sample variance. So standard deviation is square root of variance. If it is population variance. The standard deviation will be square root of the population variance. And if it is sample variance, the standard deviation will be square root of sample variance. Do you know when to use population variance or when to use sample variance? If you want to find the variance of a given data set, how will you know it is population variance formula or the sample variance formulas we have here? Now, take these two cases for example. If you have all the entire data, then you use population variance. You use the formula for population variance. Or if you only have selected data, you use formula for sample variance. So let's say for example, let's take these two cases for example. We have the score of all students in a school. The first case is we have the score of all students in a school. The second case is we have the score of 30 students selected from a school. Now for the first case, you use population variance if you want to calculate the variance for the score, because we have the score of all the students in that school. For the second case, we have the score of only 30 students selected from that school, so you use samples variance. So data selected from whenever we have selected data, you use sample variance. But if we have the entire data, you use population variance. So let's take this example. A biochemist measure the enzyme activity levels of all six samples in an experiment, and the six samples are 12, 15, 18, 20, 22, 23. So we have to find the mean enzyme activity, the range, find the variance and the standard deviation. Now, which formula are we going to use for this variance? Is it population or sample? If you check the question says a biochemist measured the enzyme activity level of all six samples. That is, all the sample we have in that experiment is six. So we have the entire data. So it will be population variance. So the first question says we should find the mean activity, that is the mean enzyme activity. That is, we should find the mean of this data. So the mean is denoted with x bar, will be 12 plus 15 plus 18 plus 20 plus 22 plus 23, everything divided by 6, and this will give us 18.33. This will give us 18.33 units per ml. 18.33. So the mean is 18.33. And is this one low dispersion or high dispersion? Is the mean close to the data set or is it far from the data set? It is close actually. So this is low dispersion. So the second question says we should find range. And the highest data here is 23 and the lowest is 12. So range will be 23 minus 12, which is 11. 23 minus 12, which is 11. So this will be the range. Then the third question says we should find the variance and the standard deviation. Now, for the variance, this is a population variance because we have the entire data. So the formula for variance is, for population variance, this is population variance. This is the symbol for population variance. So the formula is summation x minus x bar square divided by n, since we are dealing with population variance. So we have summation x minus x bar square. That is, we have to find x minus x bar for all the data. Then we square them and we add them together. Our n is 6. Our n here is 6. N is the total number of data we have in that data set. So n is 6 in this case. Now we need summation x minus x bar square. So we have to find x minus x bar square for each data set. Now the data set we have is 12, 12, 15, 18, 20, 22, and 23. So we find x minus x bar for this one. This data set they are our x. So we do x minus x bar for this one. So this will be x minus x bar, you square it. This one will be x minus x bar, you square it. X minus x bar, you square it. You do it for all the data in this question. So this is x, this one is x, this one is x, this one, and this one. Now with the first one, starting with the first one, our first x is 12. Our first x is 12. So x1 minus x bar will be equal to square it as well, will be equal to 12 minus 18.33. Then you square it. This will be equal to 40.07. 40.07. So for the second one, we have x2 minus x bar square. This will be, our x2 is 15. So this will be 15 minus 18.33. Then you square it. So you have 11.09. For the third one, it will be x3 minus x bar square. So this will be, our x3 is 18. This will be 18 minus 18.33. To square it, and this will give us 0.11. Then the fourth one is x4 minus x bar square, and our x4 is 20. So this will be 20 minus 18.33. Then you square it, and this will give us 2.79. And the fifth one is x5 minus x bar square. Our x5 will be, our x5 is 22 minus 18.33. Square it, and our answer will be 3.67. 3.67. Then this is 22. Then the last one is 6. So this will be the sixth one rather. This will be s6 minus x bar square it, which is equal to, our x6 is 23 minus 18.33 square, and this will give us 4.67. So you now add all of them together. The first one, for the first one, we have 40.07. The second one, we have 11.09. The third one, we have 0.11. The fourth one, we have 2.79. The fifth one, we have 13.49. And the sixth one, we have 21.81. So you now find the summation. That is, this is x minus x bar. This one is x minus x bar. So you now add everything together. So our summation x minus x bar square will now be, you add all of this together, this plus this plus this plus this plus this plus this, and this will give us, if you add everything together, you will get 89 89.36. 89.36. So our mean will now be, sorry, our variance rather. We are dealing with variance, not mean. Our variance will now be, remember the formula, summation x minus x bar square over n. So this will now be 89.36 divided by 6. 89.36 divided by 6. And this will give us 14.89. So the variance is 14.89 units per ml. The question, which is standard deviation, S, don't forget it is square root of variance, is square. So this will be square root of 14.89, and this will give us 0.86. So the standard deviation is 14.89 and the variance is 3. So we have another question. The question says, out of a batch of 200 blood samples, the researcher analyzed 3 randomly chosen samples for glucose level, and the 3 samples are 85, 90, 95. Now, the total blood sample is 200, but the researcher only used 3 samples. So this is a selected data. 3 are selected from that 200. So we use sample variance. The question asks us to find the sample mean glucose level, the range, the variance, and standard deviation. So the mean, our x bar, will be 85 plus 90 plus 95 divided by 3. And this will give us 90. Will give us 90 mg per year. So this is the mean sample glucose level. So the second question says we should find the range. Now range is the largest value minus the smallest value. The largest here is 95 and the smallest is 85. So the range the range will be 95 minus 85, and this will give us 10. And the last question says we should find the variance and standard deviation. To find the variance and standard deviation. And since this is a sample variance, the formula we will use is S equals, this S represents sample variance. If it is this, then it is population variance. Since we want to find sample variance, we will use S. So the formula is S equals summation x minus x bar, the same thing we did, divided by n minus 1. N minus 1. Our n is 3. So n minus 1 will be 2. Now our data is 85, 95, 90, 85, 90, 95. So these are our x1, x2, x3. So we will find x1 minus x bar, then square it, and this will give us 85 minus our x1 is 85, and our x bar, which is our mean, is 90, minus 90 square, and this will give us 25. Then x2 minus x bar square will now be, our x2 is 90 minus 90 square, and this will give us 0. And the last one, x3 minus x bar square. So this will be 95 minus 90, square everything, and this will give us 25. So summation x minus x bar square will be equal to 25, the first one, plus 0 plus 25, and everything is 50. Everything is 50. So the variance will be 50 divided by 3. 50 divided by 2 rather, sorry. The formula for our variance is summation x minus x bar square divided by n minus 1. So this one is 50, our n is 3, so it will be 3 minus 1, and this will be 50 divided by 2, and this will give us 25. So our variance is 25. So the last question asks us to find the standard deviation. Standard deviation is square root of variance. So our standard deviation, sorry, variance will be s square. Variance is s square. Variance is s square. If it is population variance, it is this. If it is sample variance, it is x square. So for this question, our variance, which is s square, is 25. Now standard deviation is s. Standard deviation is s, and you know standard deviation is square root of x square. So this will be square root of, our s square is 25, square root of 25, and this will be 5. So our standard deviation is 5, and our variance is 25.